All right, I just want to recap the module for the other day. You guys did a pretty good job overall with the solving systems of equations by graphing, but I want to hit a couple key features. Number one, I don't want to do that. Number one, we're going to essentially take two graphs and put them on one coordinate plane. That's the bottom line. Two graphs we put on one coordinate plane. So when you do the work, you'll find that they'll intersect at one point like they did over here. Did the math, blah, 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 you'll find that when you graph those two above, they should intersect at -2, +1. If you didn't, check your work again. Here's this problem here, and let me show you this answer. I did the answer here. Okay. Oh, did the answer there? Yes, 4x plus 3. Okay, so here, this one here, can I make it bigger? Oh my gosh. You full screen? Sure, let's do full screen. Oh, that's not full screen. Okay, you'll notice here when I graph this, the slope is 4/1, so I went up 1, up 4, and right 1 from 0, 0. So I start at, this is a, start at 0, 0 here. It's a direct proportion. It goes through the origin. Then the other graph is x plus 3. The slope is 1/1. It starts at 0, 3, which is the y-intercept. So I go to the y-intercept at 3, and then I go up 1, right 1, and then they intersect at 1, 4. When you show your solutions, you have to show where they intersect at. You'll notice with my graph, I show two ordered pairs for each line. Here's the red line, here's the blue line. Ordered pair here, there's an ordered pair cross up over there. But you want to be able to show that line going through there. The intersection is at 1, 4. You must write out where the intersection is at. This is one solution, one solution. This next example here, I wanted to share this with you just in case you got this one wrong. X equals 3 and y equals a -6. Don't forget y equals -6 is a complete horizontal line. Some of you guys on some of your graphs are having it's just a point. It's a horizontal line. And x equals 3 is a vertical line. Don't forget, that's our vertical line. It's undefined slope. So draw them out completely. And this intersection should be at 3, -6. As you can see from the answer, it is. All right, so when you graph those solutions, you'll be able to, those equations, you'll find one solution. That's what we're trying to do here. Now, so this check is over here. I did do this, yes. X equals a -1 is a vertical line. Y equals a -4 is a horizontal line. Again, where are they intersecting at? That is the solution. -1, -4, that is the solution. Now, sometimes they don't give us the equation in slope-intercept form, so we have to rewrite it. And so when you rewrite it, you simply have to solve for y, get y all by itself. Do what you need to do to get y all by itself. Let me show you what they did over here. So in this case here, for this example here, for this check, I have y minus 2x equals 4. I added 2x to both sides, so I get y equals 2x plus 4. The slope is m equals 2, so I go up 2 and right 1. From the intercept is 0, 4. Now, the other graph is y equals 2x. It's already in slope-intercept form. The intercept, 0, 0, is the origin, and that's where this happens to start from. So I go up 2, right 1, up 2, right 1. Oh my gosh, I graphed this one wrong. I'm at 0, -4. Okay, well, that's a 0, -4. That's not 0, +4. Oh, that looks goofy. Sorry about that, guys. This is a wrong graph. Hopefully, oh, that will be the phrase that pays. Wrong graph. So my graph, y equals 2x minus 4, because it's 4 units down. If this is +4, it'd be up here. Either way, there's still parallel lines because the slopes are the same. That's the big key. There's still parallel lines, the slopes are the same, and goodness gracious, that graph is wrong. Next time, I'm not going to find my mistake. I'm going to make you guys email me the mistakes, and you'll get extra credit. Darn it, sauce. Opportunity missed. That's okay. But don't forget, when the slopes are exactly the same, the lines are parallel. When the slopes are the same, the lines are parallel. The intercepts are the only thing that differs. Okay. Again, here's our parallel lines, blah, blah, blah. Okay. Now, here again, our slopes are exactly the same. The intercepts are different. That is the biggest thing to come up with. When the slopes are the same and the intercepts are different, understand that the solution is no solution. Because there are no intersections of points, it is a no solution. Make sure I highlight that. No solution. Did I say that in my thing over here? I don't really remember. Yes, no solution. Okay. All right, let's go to the next guy over here. We did that problem already. So sometimes the lines are the same. They disguise them a little bit, but they're exactly the same. If you take a look at this example here, they have y equals 3x plus 5, and here it's -3x plus y equals 5. They just rewrote that. they added 3x to both sides, end up being the same line. Generally speaking, it's the same line, it's just written in a different format. So go ahead and take a look at this problem right here, this check. You already did this one, y equals negative 1/3 x plus 1, and then this one here, you have to go ahead and solve for y. See if I did this one right. Holy cow, that one looks right. Okay, so you go ahead and you subtract a negative 1/3 x from both sides using our properties of equality, and when I do that, I get the same exact equation. They're both the same. When I graph it, it's the same line. Therefore, it's an infinite number of solutions. So when you graph that, you'll find it's an infinite number of solutions because that means any point I pick off the line, okay, any point ordered pair I pick off this line works for this equation and this equation. Obviously, it makes sense. In this case here, I could pick any ordered pair. No ordered pair will ever satisfy both of these equations because they are parallel lines. They never intersect. Here I have one point that works for both of them. That they intersect at that one spot. That's one solution. And let me turn this off. I don't know. I gotta turn this off somehow. It's someplace I lost it. All right, so you guys have an understanding, and your assignment is to do 329 to 330, 1 through 7 all. Once I can figure out how to turn this off, I'll turn it off. I think. Okay, this is embarrassing. This always happens to me.